In this video, I'm going to describe first transition analysis for computing absorption probability. Our goal is to compute the probability of being absorbed at a certain state given that we start at state x. This looks like u of x equals the probability of absorption at our state of interest given that x0 is equal to x. For our state of interest, this will be 1. For all other absorbing states, u of x is equal to 0. This makes sense because if we start at our state of interest, then the only place that we can go is back to that state, and we have a 100% chance of being absorbed at that state. If we start at a different absorbing state, then the only place that we can go is that absorbing state, and u of x is equal to 0. So for all other states that aren't absorbing states, u of x is unknown, but we can use a system of equations while conditioning on the first step to solve for u of x. Okay. We do this using first transition analysis or for first step analysis. Generically, this looks like this. We are iterating over every possible first step and seeing the probability of absorption at S given x0 equals x, our starting point, and x1 equals every possible value that x1 could be. Then this is times the probability of x going from x to our first step k. So this might be a little bit confusing. So let's look at a practice problem. At a local 2-year college, 60% of the freshmen become sophomores, 25% remain freshmen, and 15% drop out. 70% of sophomores graduate and transfer to a 4-year college. 20% remain sophomores, and 10% drop out. We want to use a Markov chain with a state space equals with 1 equal to freshman, 2 equals to sophomore, G equals graduate, and D equals dropout. And notice that G and D are our absorbing states. So our question is, what fraction of new students will eventually graduate? This is what fraction of freshmen will eventually end up in state G for graduating. The first thing we should do is build the transition matrix for this problem. This is what the transition matrix looks like. Next, we can use our formula that we came up with up here to find u of 1 for being absorption at G. So we define u of x as the probability of absorption at G given x0 is equal to x. And we want to find that for u1. So u1 will be the answer to our problem. We know that ug is equal to 1 and ud is equal to 0. This makes sense because once a student has graduated, they will stay in that state. And once a student has dropped out, they will stay in that state and won't end up graduating. Next, we just need to find u1 and u2. That looks like this. So the summation of the probability of absorption at G given x0 equals 1 and x1 equals k times the probability of going from state 1 to state k. We can plug in the values that we have in our transition matrix to solve for these values. So 0.25 times u1 plus 0.6 times u2 plus 0 times ug plus 0.15 ud. And we already know ud is 0, and we can cancel out this 0. So we know that the system of equations that we use, the equation that we'll use for finding u1 is this. Then we have to just do the same thing for u2. So 0 times u1, 0.2 times u2, 0.7 times ug, and 0.1 times ud. So the equation for u2 looks like this. We can combine our equation for u1 and u2 to make a system of equations out of this. And when we solve, we get u1 is equal to 7 out of 10, and u2 is equal to 7 over 8. And thus we can conclude that 70% of freshmen eventually end up graduating because u1 is equal to 7 over 10.